Hi, welcome to our next lesson. We'll be dealing with factoring quadratics by grouping, but instead of having your leading coefficient with 1, it will be a number greater than 1. So the objective is, how do we factor quadratics by grouping with a lead coefficient? Before we even get into figuring out how to factor with a leading coefficient, we need to know what leading coefficient means. So coefficient, it's a number written in front of a variable with the largest exponent. So the first example you see here, each number for each term is a coefficient. And then if it's by itself, a number by itself, then it's a constant. But in order to determine which is the leading coefficient, it is the one that has the highest exponent or highest degree. So in the polynomial below, we can see that 3 is the highest degree, and what's in front of that term? 4. So 4 is the leading coefficient of this polynomial. So when it comes to grouping, we're using factor by grouping, especially when we're dealing with leading coefficients. Just going to make this a little bigger. There are 3 things to consider. Is your polynomial is a trinomial. If you have 4 terms, 5 terms, then no, you wouldn't be able to use this method. Second thing, the highest exponent or degree is 2. So again, when you deal with quadratics, you got x squared plus 2x minus 5. So your degree is 2 in the first term. And then 3, the number in front of the variable with the exponent of 2 is not 1. It has to be more than 1. So when it comes to factoring a trinomial with a leading coefficient, the very first thing you're going to do is check for the greatest common factor. What is greatest common factor? GCF. You already learned about pulling out the GCF when it comes to factoring binomials or even trinomials with the leading coefficient where it's 1. So we have an example, 7x squared plus 29x plus 4. We're going to use factoring by grouping when it comes to having a leading coefficient. So the first step is to make sure that your trinomial is in standard form. You already learned what standard form is. If you forgot, standard form is basically the degree of the variable going from the greatest to the least. So highest to the lowest exponent. So what you're going to do is you're going to multiply the first and the third numbers. So notice that I highlighted in blue is the first term, and the third one is 4. So when you multiply those two, you will get 28. Right. The second step is you write out the factors for the numbers you got when you multiplied. So we're going to be looking for the factors of 28. So in this case, it's 1 and 28, 2 and 14, and 4 and 7. Right, so now, third step, rewrite the polynomial. So what we're going to do is we're going to keep the first term, which we started off with was 7x squared. So 7x squared. And then, sorry about that, replacing the middle term with 2 factors that you found to add it up to keep, sorry, 2 factors that you found to add it up to it. So 29, what 2 numbers can we use? 1 and 28. So then we're just going to split it. And then you keep the last term the same. So again, we got from here, we multiplied the first and the third numbers to get 28. We found the factors of 28, and then we found the 2 factors that would give us the middle term of 29. It's almost as if though you were doing a simple factor by grouping, but again, you're still dealing with a leading coefficient. All right, so that's the third step. Fourth step, now you should have 4 terms in your polynomial. So notice that you have 4 terms, and it's down here. And the fifth step, from there, you've done this before, you create 2 sets of binomials and find the GCF for both of them. So with this one, broken into two, found the GCF for the first group, found the GCF for the second group, and then from there, you place the GCF into one group, and then you place the common factors in another group. So notice that inside the parentheses, it's the same expression. So that's going to be its own group, and then the GCF are in their own group, the second group. And there you go. You have your two factors that will give you what we started off with at the beginning, which was 7x squared plus 29x plus 4. So again, you already did group factor by grouping when your leading coefficient was 1, but you just add in a step, just one step before you get to that point. So you multiply in the first and the third term in order to find the factors, so that way you can split the middle term and then do the factor by grouping. All right, so let me expand that. So basically, that's the step. So we're going to see an example using the steps that we just learned. So we have 3p squared minus 2p minus 5. So the first thing we're going to do is label your A, B, C, D. So that way, when we have to do the product and the sum, you know what to multiply and what two factors you need to find for the sum. So A, B, C, again, it's in standard form. That's, well, the very, very first step is GCF. Is there any GCF that you can pull out? No. So we don't need to worry about that. Is it in standard form? Yes, because the degree is coming from 2 and going to 0. All right, so now we have our label. We're going to multiply C and A, which will give us negative 15, and then we're going to find all the factors of negative 15. So notice that I have 1 and negative 15, 3, and negative 5. The reason I have the negatives with the bigger number for each set of factors is because my middle term has negative 2. So that means whatever two factors I find and I add them, I have to end up with a negative. So that negative has to stick with the bigger number in order for that to happen. So now my sum is negative 2. Now I look, which one will give me negative 2 when I add the two factors? 3 and negative 5. So with that, I split it. So then I have 3p squared plus 3p minus 5p minus 5. So I got 4 terms. Now I can create two sets of binomials, then find the GCF of each. So for the first group, it was 3p that they have in common, and then for the other one, negative 5. Notice that I pulled out the negative 5 because when I end up with the common factor in the parentheses, I want them to have the same sign, and so that way they can be grouped together. So once I do that, I bring down the GCF, and then I divide each term by the GCF, and then lo and behold, I have p plus 1 for each of them. That will be its own group, and then the GCF will be in its own separate group. And there I found my factors. And again, always self-check. If you're not sure that you got the right factors, there may be a mistake, you're not sure of the sign, always just multiply either by FOIL, box method, and see if you end up with what you began with. If you did, then you did the right thing. If not, then you got to check your sign, your math, or any other stuff. All right, let's go on to a second example. 2n squared, oops, sorry about that. 2n squared plus 3n minus 9. All right, so GCF, we got to pull out a GCF. Is there any GCF to pull out? No. Is it in standard form? Yes. All right, so now I can label it. My first term, A, the first coefficient is A, second B, and then third is C. Notice that whatever sign is in front of that number has to be attached to it. Now, first step, I'm going to multiply A and C, 2 and negative 9, which gives me negative 18, and find all the factors of negative 18. So I had negative 1, 18, negative 2, 9, 3, negative 6, and then I have negative 3 and 6. Because my sum is positive 3, and I know that 6 and 3 I can use, but if I have to add them, one of them, the smaller one, has to be negative because I ended up with a positive number. So 6 would be a positive one and then 3 negative. Those are my two factors. Now I can use that and replace the middle term and create my four terms. So 2n squared minus 3n plus 6n minus 6. And let's say you put 6 plus 6n first and then minus 3n. That is fine. As long as you find the correct GCF for each set of binomials that you created, then you should still end up with the same answer. All right, so now find the GCF for each binomial group. First one is n, the other one is 3, and then bring it down and divide. And I got 2n minus 3, and then the other one 2n minus 3. And since we have the same purple binomial group, they are going to be together, and then the GCF n plus 3 in its own separate group. And for this one, yeah, there's negative there. So let's say you did pull out a negative, which I did before, but I changed it. When I had negative 3, and then when I brought it down, I noticed that my factors in there, I got negative 2n and I got positive 3. It didn't match up to that. So then I had to pull the negative out, which made the 3 positive, and then get 2n minus 3. So that's going to be a situation where you might take out a negative and then you still end up with the factors inside the parentheses being different based on sign. You just pull it out. Whatever you pull out, or if it's a negative, then you have to multiply to the GCF that's outside in front of that parentheses. Okay, let's go for another one. All right. Let me go back to that one. So that should say example 3. So let me just change that so that way it matches with what you have in your guided notes. Now let's try that again. Okay, so for this one, it says check for GCF first. All right, notice that we have 3, 24, and 48. We all know that 3 can go into each of them. So the first thing you do, well, I just rewrote it. I put GCF. Check for that. You can divide 3 into all of the terms. So then you end up with, inside the parentheses, x squared plus 8x plus 16. But remember, whatever GCF you pull out has to be in front of that parentheses. Don't just completely eliminate it because it's part of that. Because it's part of what you started off with, and if it disappears, then whatever you get is not going to be equivalent to what you started off with. So now we have a trinomial that does not have a leading coefficient. So now we can do the regular method where you do either product sum or you just do the shortcut in order to get your factors. So for this one, I did 2 sets of binomials. Notice that I'm bringing down the GCF because that's still part of that work. Because that's the first thing you took out, but it's still part of the trinomial. So I did 2 sets of parentheses. Look at my signs. I'm starting with a plus. That means I'm keeping both of them as is. And then I find the product. Well, we already have the number there. So you find 16. Make sure you don't go to the original one. Go to what you went down to when you took the GCF out. So you find the factors, and then of course 8, 4, and 4 gives you 8, and then you put it in, and then you have your answer. You could leave it this way, or you could distribute the 3 to the first term and then get your 3x plus 12 times x plus 4. So if you were to leave it in this form or the other form, I would accept one or the other. It doesn't matter. All right, so for this one was one of the examples where you had to check for the GCF. If you can divide a factor, a common factor, into each of the terms to make it your trinomial smaller, do so. sometimes you're going to have some big numbers, and especially when you have to use factor by grouping and you have to multiply, you're going to get some big, huge number where you have to find factors for it. If you can avoid it, do the GCF first. That will reduce the number, so that way you have something decent to work with. And remember, whatever GCF you use, bring it down all the way to the end of your work. All right. And again, this one should be example number, make sure I have the right one. So example 4. Okay, so for example 4, we have 2x squared plus 5x minus 2. All right, so I have my a, b, and c. There's no GCF, and it's already in standard form. So now I'm going to multiply a and c. So it's going to give me 2 times negative 2 gives me negative 4. And I'm going to find all the factors of negative 4. So I have 1, negative 1, 4, negative 2, and 2. And the reason why I have the bigger number as positive, because I want to end up with a positive number for the middle term of b, which is 5. All right, so now I know the sum is 5, but now I'm looking at my factors. I noticed that, okay, 4 and 1 would give me 5, but based on the signs, it would not work. So I can't go anywhere with this because I can't find the factors to give me the middle term. So when you run across a problem like that with any trinomial, this is called a prime polynomial. And a prime polynomial is a polynomial that cannot be factored with integer coefficients. So that means it's not factorable. So you cannot do anything with it. It just stays like that, and that's all you can do. So pay attention to what your signs are, because especially you might try to put 4 and 1 and then try to factor it, but if you were to take the terms and try to factor to get to your product, you're not going to end up with the same thing. So be careful, because in this situation the sign does matter. So that means your 2 factors for negative 2 will never add up to positive 5. So don't force it. If it can't happen, that means it's a prime polynomial. And all you just have to write is not factorable. Right. So we went through a few examples dealing with factoring by grouping with a leading coefficient. So let's see. So we learned about that leading coefficient is basically a number in front of the variable and the exponent with the highest degree. So again, the word leading is in the definition. Leading coefficient, something's leading, it's the leader, it's in the front, it's taking the lead. So the one that has the highest degree takes the lead. And you also learn the steps when it comes to factor by grouping, but the 3 things you need to know in order to use that is that it has to be a trinomial, the highest exponent has to be 2, and the degree in front of that variable of the exponent of 2 has to be greater than 1. And when you go through the steps, check for the GCF, make sure that you can pull out a GCF just to make a trinomial coefficient smaller so you can manage it when you factor it, and make sure it's in standard form. Because in order to do that, and then especially when you have to divide the GCF, you need to be in that standard form. So first thing, you multiply the first and the last numbers, and then you find the factors of that number, and then keep your first and last term the same, and then the middle term will be replaced with the factors that you found. Don't forget the variable behind it. Then you have your 4 terms, then you break it up into 2 sets of binomials so you can find the GCF for each. Divide the GCF into each term, pull down the GCF, and get the remaining factor will be in the parentheses. If it's the same, then it's going to be in its own group, and the GCF will be in its second group. And that's factor by grouping with a leading coefficient. And if you run across a trinomial where you cannot factor it, because you cannot find the factors to give you the sum, then you just say not factorable and don't touch it, because you can't go any further with it. Alright, so this ends our lesson. If there are any questions, you know that you can email me and I can provide you examples so that way you can understand it. Alright, see you around.